Hi, I'm Skipper Don. You've seen the first few videos, but let me take you through building and some of items that you will need. At first, I wanted to keep the design simple, but after reviewing my own videos, I realized that with the complexity of D3KOS and its AI integration, the right hardware and components actually make the system both easy to assemble and effortless to use. Now look at here on the 32-inch screen. When you're running an open helm like this, the display's power draw is substantial, especially for high brightness screens exceeding 1500 nits, which can consume hundreds of watts just to maintain full daylight visibility. It's so hot that you can cook a sausage on it. Taking power in consideration is paramount. I base the design on 12-volt battery, but the more you put onto it as options like the power over Ethernet, cameras, and monitors, you may need to look at this moving forward. So let's get started. A number of years ago, opening boxes and envelopes videos was a thing. Not sure if it is or not, but that is how we will start. The first tip is to build this on DIN rail system. You can get Raspberry Pi's DIN rail holders, and this is an excellent method to connect your electronics in a NEMA IP67 enclosure. For the heat sink, I choose this model as it has a pass-through for the GPO pins. It also is not flush against the Pi. This ensures movement of air. The OS sometimes uses all 4 cores and will use 8 gigs of RAM to the max. To prevent the Pi to throttle down or even reboot, a heat sink with a fan is a requirement. I have taken steps to ensure that when items like RAG and AI are working together to be able to release these applications, when not being used to manage the Pi's operation. I initially bought the Pick-and-M case, which I have on my boat, which is running open plotter. I don't have a heat sink, and when the outside temperature reaches 30 C or above, the Pi does throttle back, and most time reboots. Having a heat sink between is a must, but the case will not work without a heat sink with a fan. But here is a trick. Get a box of M2 to 3 to 4 brass spacer and standoff screw nut set. Buying something precisely is difficult. Figuring what you actually need, especially when it comes to stacking the Pi with a heat sink and a Pick-and-M hat, can be challenging. For this video, I ended up replacing the offsets 3 times before I got this to line up. DIN rails are really industrial, but for items like Raspberry Pi, small network switches, and other Internet of Things, it becomes practical in terms of mounting. I tried to use a plastic board and screw on the Pi and other components, but it's really labor-intensive, and this easier and repeatable. Mini HDMI on the Pi and regular HDMI plug that goes to the touchscreen monitor. Do not use adapters for this, as monitor touchscreen may not work. During this initial build, I use house current to test and ensure that everything boots up properly and is working.